All right, class. So in the last class, we had completed with still center of mass entire topic was completed. One more thing I forgot to tell you all those who were having their backup classes, Terim and all. See, last Friday I couldn't take the class because some other classes were there already. So this Friday we'll have the backup class. All right. Motion in a straight lines, backup class will be there this Friday. Timings, I think the timings will remain the same, but once again, I'll just confirm it with you on Wednesday. All right, rest of the timings for the backup classes will be the same. From in India's timing, we have it from 7:30. So at your place, just check at your end whatever is the timing that is present. Otherwise, this Friday we'll have the backup class for motion in a straight line. We already had it for calculus, differentiation and integration. This we had completed. So this Friday we'll have the backup class for motion in a straight line. Timing, once again, I'll confirm with you on Wednesday. Just remind me once if I forget. But all those who want to join, this is not compulsory class. Those who want to join, they can. Those who want to have the revision, they can. Fine, class. Now see kinematics of rotation motion. See, class, this is not a difficult topic. Center of mass was a new topic, completely new topic for all of you, right? Center of mass you didn't study. Center of mass was what? It was the point that was assumed where the whole mass of the body was supposed to be concentrated, right? Now see, linear equations you have studied, no? All the linear equations, V is equal to U plus AT, V square minus U square is equal to 2AS, S is equal to UT plus half AT square. All these equations you have studied. So you just have to understand what is the rotational analog of each term, and the rest of the equations will remain the same. See, instead of displacement, use theta, that is angular displacement. This is angular displacement. So whatever term, wherever you were using S, that is for distance. Now this becomes angular displacement, theta. Similarly, initial velocity you had. So this initial velocity, this will become initial angular velocity. Just understand the terms. Once you've understood the terms, then it will become easier for you to remember. So initial angular velocity. Similarly, final velocity we had. Again, here also you will be having final angular velocity. And ultimately you have acceleration. So here also you have angular acceleration. All these terms we have studied though in circular motion. So this is angular acceleration. Now it's very easy for you to relate all the terms. Right, see, V is equal to U plus 80. This is for linear. Yes. Someone was asking. Yes, Sarah.
Your voice is breaking, ma'am.
My voice is breaking. Okay, just a minute. Just let me know if the voice again breaks. Because today there is some internet issue, so it can happen that my voice will crack in between. So just let me know. All right, so one side, yes, I was writing on one side the linear equation, and on one side I'm writing the rotational equations. Is it fine now?
Yes, ma'am.
Okay. Please interrupt whenever it's, because here today some internet issues are there. So here I have rotational analogs. So see, this becomes just whatever you have on this side, no? Just substitute it with this. Rest is absolutely as it is. That is omega is equal to omega naught plus alpha t. See, time is definitely same in every quantity, be it rotational, be it linear. You do not have something else for time. So time will be there. Rest of the equations. S is equal to ut plus a half at square. So this becomes theta is equal to omega naught t plus half alpha t square. And this is v square minus u square is equal to 2as. This becomes omega square minus omega naught square is equal to 2 alpha theta. So these equations you will be using. Same things, whatever you have studied for linear, same thing will be here. All right. Now, using simple integration, or you can even derive this. Even using basic simple integration, you can derive this as well. All the points that you have studied over here, this point, all these you can derive it by yourself. Now, see how can you derive this. Derivation is not difficult. You can see for the first equation, let's see. Just in case if in your school exam it comes, for that this derivation is there. If in your school this derivation has not been done, do not revise it before the exam, because then it won't be asked. Because these are not very much important in the rotation lesson. There are other derivations also that can come from rolling and all. See, angular acceleration is what? D omega over dt. That was entire circular motion what we were studying. So alpha dt will be equal to d omega, right? And d omega is the change in the angular velocity in time dt. So if we want to change it from some 0 to t value, we'll do what? We'll perform integration. And omega will change from where? Initial velocity to final velocity. Right. And alpha angular acceleration is constant. So alpha dt 0 to t is equal to omega limits omega naught to omega. Integrating t will give you t to the power 0 to t, the limits from 0 to t, and omega limits omega naught omega. Now see class, just substitution of the integration products. Upper limit minus lower limit is equal to upper limit minus lower limit. So see, this becomes omega is equal to omega naught plus alpha t. You have this equation there. So like this, you have the basic derivation. This was very easy. Second one is also, it's just a little lengthy, but it is not difficult. See, for the second equation which we have, theta is equal to omega naught t plus half alpha t square. So wherever you forget these equations, no, for rotational equations, immediately write down the linear equations and then substitute each of the terms. All right, like force will here become torque. So everything like this, you just have to relate. Now see here how you can start with omega. Just now class, for these derivations, remember the first steps. If you do remember the first step, then simple integration, you have to exceed it. So here omega is d theta over dt. So omega can be omega dt can be written as d theta. So same thing, time from 0 to t I have to expand, and theta also from 0 to final limit, that is theta. And one more thing, omega's value we have now, no, omega is equal to what? Omega naught plus alpha t, we already have the value of it. So substitute, if you have the value of omega, substitute it in the main equation. So that becomes what? That gives you omega naught plus alpha t instead of omega dt. 0 to t is equal to integral from 0 to theta dt. The rest of the things will remain the same. Now class, we just have to integrate it. Before that, let's multiply each of the term with dt so that our calculation can become easier. 0 to t plus alpha t dt from 0 to t. This is equal to d theta from 0 to theta. I think now you are even able to see your answer. The equation has almost been derived. See, omega naught is a constant. T limits from 0 to t will remain. plus alpha is constant. T integration, the integration of t, it's t to the power 1. So add 1 in the numerator and divide it by the term that you're getting. That is t square divided by 2. Limits 0 to t is equal to theta, limits 0 to theta. So omega naught is upper limit minus lower limit plus half alpha is there. Upper limit minus lower limit is equal to upper limit minus lower limit. So here we have the equation back. Omega naught t plus half alpha t square. That's why I'm saying, even if you remember it, it's not very difficult to learn. But by chance, if it in your schools, it has not been done, so then it is not very important. But yes, questions will come. Questions are there in your syllabus. And last equation, omega square minus omega naught square is equal to 2 alpha theta. So we'll start again from here only. Alpha is equal to d omega over dt. But see, if you multiply and divide by d theta, upper and lower both the sides. Class, do you see this term, d theta over dt? Is it any term, d theta over dt? From your knowledge, what we have studied, d theta over dt, is it any term? We have just done it. In the above derivation, we were doing it.
Angular velocity.
Yes.
Yeah.
Good, Aram. It is angular velocity. Omega is d theta over dt. Till now we have been doing this, no? Alpha is d omega over dt. Please be clear of all these terms. This is just like velocity is the displaced rate of change of displacement, and acceleration is rate of change of velocity itself. Related with your first lessons which you have done. All right, so this is omega. Omega is equal to d theta over dt. So alpha will be equal to omega d omega over d theta. Now cross multiply. So alpha d theta is equal to omega d omega. Again, let's just integrate it from the minimum value, that is 0, to maximum value theta. And this from initial value is omega naught, final value is omega. So alpha is a constant term, theta 0 to theta is equal to omega. Now omega square by 2 will be left. Why? Omega to the power 1 is there. So plus 1 divided by this term. We have already discussed integration, but anybody who is having difficulty in integration, please let me know. Since I have discussed it, that's why I'm assuming you all remember it. If anybody is having difficulty, please let me know in the basic integration. Now, after this step, what we are left with? Alpha theta. Okay, we have got our answer. Upper limit minus lower limit by 2. So yes, omega square minus omega naught square is equal to 2 alpha theta. So all the three equations derivations are there. Mainly, even remembrance of these equations are not difficult. So note it down all these points, then we'll see numericals on this. Now see, this question says that on application of a constant torque. So torque, I have told you, I'll discuss this in detail. This is included in your syllabus. This is basically rotational analog of force. Like if you use F is equal to MA. Okay, moment of inertia also not we have done. So force becomes torque M becomes moment of inertia, A becomes alpha, like this. All the rotational analogs will remain as it is. So this is on application of a constant torque. A wheel is turned from rest through 400 radians. So initial velocity, this is final velocity, this is the time that is taken. You have to find out alpha and final velocity if time is this. See, for the first part, angular acceleration, we can use this equation, theta is equal to omega naught, because see, 400 radian is no, not omega, this is theta. Displacement is given. No, theta is the displacement. Radian is the SI unit also of displacement. Otherwise, it would have given radius per second for velocity. For angular acceleration, it would be radian per second square, like this. So omega naught p plus half alpha t square. Any equation we can use, because here everything is getting fit. So that's why I'm using this. Also class C, this is 0. So this entire term becomes 0. 400 is equal to half alpha, and time was given 10. No, so that becomes 100. 0, 0 gets cancelled. Alpha becomes 8 radian per second square. Second part says angular velocity if time is equal to 20 seconds. So see, final velocity is equal to omega naught plus alpha t. Final velocity will be, initial is given nothing. This is again at rest. So 0 plus alpha we have calculated from this part. So 8 into time is given as 20. So omega becomes 160 radian per second. 160 radian per second. So alpha is calculated from this part, omega from the second part. Note down this question, then we'll do one more question. Aisha, your mic is on.
Yes, ma'am.
Class C, there are certain conversions that you should be aware of. When one rotation is given to you, you cannot keep your answer in rotation, because rotation is not the SI unit. SI unit for displacement is what? Angular displacement. It is radian, right? So one rotation, it will be written and converted as 2 pi radian. Or if you have one revolution as well, one rotation or one revolution, this is written as 2 pi radian. If you have to write one rotation per minute, sometimes in the question it is given as RPM, right? It is given revolution per minute or rotation per minute. So this basically means one revolution per minute, RPM. So revolution per minute. In some questions, most of the questions you will find there's maximum questions. So that becomes 2 pi radian divided by 60 seconds. So that becomes pi by 30. So one rotation per minute is equal to pi by 30 radian per seconds. Understood? For omega, 1 RPM is equal to pi by 30 radian per second. So if 3 rotation per minute or 5 rotation per minutes, like this it is mentioned to you. So do convert it by yourselves. This is important. One question let us do before we begin with the next topic, that is torque. C class, let us just discuss this question, then you can note down all these points together. See, it says that angular speed of a motor wheel increases from 120 rotations per minute to 3,120 rotations per minute. And time duration is given as 60 seconds. So everything is given. Initial velocity, final velocity. It means initial angular velocity, final angular velocity. Time is given. Alpha is just missing. Acceleration is just missing. One linear equation is required. But see, we cannot use it directly. Seconds is there in SI unit. Everything is there in SI unit. But initial velocity, that is 120 RPM, we cannot include this. So as discussed, either multiply by 2 pi by 60 or multiply by pi by 30. Same thing, you will get it here. So this becomes 40. Right. 120, 1200, then it will be 40. Because how can it won't increase so much? Make just it in your, when you'll write it now, make it 1200. Then only it can increase at a significant rate. Otherwise, such a huge amount of increment is not possible. So this is omega 40 radian per second. This is what? This is initial 40 pi radian per second, right? And what about the final one? Final one, which is omega. This is the initial one. And final one, that is 3120. 3120 RPM. So 3120 multiplied by 2 pi by 60, same thing again. So that doubles it and then divides. So that becomes 104 pi radian per second. Just keep on checking the calculations. If there is any need, just let me know. And time duration is given to you as 16 seconds. Initial velocity you have, final velocity you have, t you have, alpha is just missing. Which equation you will use, class? Which equation you think is preferable to use here in this situation with all these variables and constants given? Yes, Talha, any answers from you? Alpha is missing. Time is given, initial velocity, final velocity is given. So according to you, which equation of motion should be used? Terim?
From the first equation.
First equation, yes, correct. It will be the first equation. Omega naught plus alpha t. Now clear, Talha, why did we use this? Because only this is missing. The rest of the things are. If you use, okay, if you use second equation, you require theta. For third equation, you require theta. That's why we had to keep this. All right. So this is 104 is equal to 40 pi. Here you have pi plus alpha into 16 times alpha. So we'll get our answer in terms of pi only. You can multiply it at the last. So 16 alpha. So alpha becomes 64 pi by 16. Alpha becomes 4 pi radian per second. Like this you calculate. And second part was same. Let us just read the second part. How many revolutions does the wheel make during this time? It means wheel is moving. So how many revolutions? Revolution and rotation. I hope you all know the difference. When the body doesn't translate, when the body just moves around a fixed axis, you call it as rotation. But when the body completes motion in orbits around anything in circular path, that circular path is known as a revolution. So there's a difference. All right. Now see, for this, we have to find out theta, because without knowing theta, if we do not know how much angular displacement has been covered, how will we get to know how many revolutions are there? So now for theta, you can use any of the equations. Let us use the second equation. So theta will be omega naught t plus half alpha t square. So theta will be 40 pi into 16 plus half into 4 pi into 16 square. So when you'll solve this, you will get theta as 1152 pi. Now see, 1 revolution is equal to 2 pi radians. This is given in radians. So 1 revolution is 2 pi radians. So 1 radian is how much revolution? 1 radian is 1 by 2 pi revolution. We have to find out number of revolutions. Class, basic unitary method. Just pay attention. 1 revolution is 2 pi radian. So 1 radian is 1 by 2 pi revolution. If 1 radian is 1 by 2 pi revolution, so 1152 pi radians will be how many revolutions? We'll just multiply it. So 1152 pi radians. This will be 1 by 2 pi into 1152 into pi. Pi gets cancelled. You get 576 revolutions. So simply using unitary method, you can solve all these questions. This is the number of revolutions. Noted down. Any doubts you have from this topic? This was a very small topic. As I have said, all the equations of motions have been repeated in just rotational terms. So everything is same. It's just that new analogs are there. So wherever you have difficulties, let me know. Then after this, I'll start with torque. That is a different new topic. Okay, class. Now say regarding torque. So as I was saying, rotational analog of force. Rotational analog of force means what? Whatever work force was doing in translational motion. Same thing is done by torque in rotational motion. So moment of force is basically the moment of force. So moment of force, and yes, one thing. In case of linear motion, in case of normal linear motion, you don't have rotation, so you do not need axis. If you do not need axis, then there is no need of any pivot motion to occur. Now, in case of torque, what's happened? Moment of force is there, but around a fixed axis of rotation. Without axis of rotation, you cannot have torque. This is the main difference between torque and force. And that's how it makes torque different from force. One axis of rotation is required. In case of force, you do not have any action of force. No. Suppose a person is moving on the ground, right? Normal reaction is occurring, weight is occurring. If somehow some external force is applied on the body of the man, then what will happen? The force, the man may get displaced a little forward. But see, class, in all of these, you didn't have any reference point where you had started. If this man, if different forces are acting from all the directions, you allowed it. In case of torque, you have a specific axis of rotation. So torque is what? Torque is basically moment of force about the axis of rotation. Moment of force about the axis of rotation is torque. This is known as torque. In torque, no, torque is also not a difficult topic. Now, among the difficult topics, when you have moment of inertia, which is left, we'll discuss it in the next class on Wednesday. And one last topic that will be left will be rolling motion. So on Monday, next week, we'll complete this lesson and we'll start with the next lesson as well. Now, C class. And also class, one more thing, your class duration will also increase soon because 1.5 hours will become very less for the completion of your syllabus. And I think most of you have your exams starting from Jan, Feb, all these days, no? Because the 12th class starts a little earlier. So 11th class usually ends earlier than the 12th class ends. Because in March, you have most probably your 12th classes starting temporarily, but they get started. So I think all of you must be having your exams by this time only. When are you all having your exams? Do you have any idea? I think Aram told me that she was having her exam in Jan. Right,
Yes,
Aram?
ma'am.
And what about others? If you know whenever you're having your exam and if you get your date sheet, please update me because I'll then manage the syllabus speed according to that only. Because this session started late, no? Because your 10th boards were very late. Done just 2 days ago. Final exams, Yusuf. 11th class over. Midterm. No, that I understand. Midterm, I understand. I'm asking about the final exam of class 11. If you all get to know about that, so let me know. So how did your exam go, Yusuf? Physics exam and all rest of your papers as well. How was your exam? And others also, apart from Aram, Yusuf, if you all get your schedule. Tareem, you also let me know. Abdullah, Tarif.
Yes, ma'am.
Okay, just
Ma'am.
yes, Aram.
Yeah, I got my schedule. I'll send you.
Okay, you've got your schedule. Okay. Okay, Yusuf. Now, see, position vector is what? Let's say R is some position vector. Because this has a key role in torque. We'll just complete with torque and then I'll stop the class. And theta is an angle that is present between that force, linear force that is acting and the position vector. I'll write down the complete statement. Angle between force and R. Force and R. So linear force and R. That is required. Why? Because of the formula of it. C class. Just understand torque once. The formula is easy. Formula is very easy. I'm telling you, this is one of the easier topic from here. Difficult topics, you have moment of inertia and rolling motion that we'll see later on. 2 classes are needed. So next Monday, we should get over. So this is torque, let's say, that is acting. This is the origin that I'm saying. Let's say some point I have taken. This is some P point which has a separation from this vector as R. And a force is, let's say on this point, P point only, force is acting, F force is acting. So if I extend this, this becomes the angle theta between the force, right, from the point of application, right? This becomes the angle. Or let me just decline this inclination of this angle, because one small, very small derivation is there. This derivation can be asked in your theory part, like along with 2 other questions, it can be asked to you. So let's say this is P point. This I am extending. And this is the force that is acting. So this becomes theta angle. Or you can say this is also theta because of vertically opposite angles. Remember class, R is always the perpendicular displacement. Always the perpendicular displacement. You do not take R from anywhere. It has to be perpendicular. Like this R is not perpendicular. So I'll drop a perpendicular from origin because this R is now not valid. Let's say I have dropped a perpendicular. This is our perpendicular. Let's say this is some point N or P were already there. I have marked this point. This is N. Now see, if you look in this triangle, O and P that has been formed, sine theta, if I write, C class, this is a triangle. This is the perpendicular ON. Right, hypotenuse OP, base PN. So sine theta will be what? Perpendicular by hypotenuse. So that becomes ON by OP. Right. Now C class, ON is R perpendicular. OP was simply the position vector R. So R perpendicular becomes R sine theta. And torque. Torque is equal to RF sine theta. Torque, the formula of torque is RF sine theta. Right. So see, if you put this as RF sine theta, why? Because see, torque is acting on the rod. So definitely this will be R multiplied with this force and whatever is the angle between them. But if you write this RF sine theta, then do you see R into sine theta is R perpendicular? It means torque can be written as this torque, same value. This can be directly written as R perpendicular into force, even without writing this. Or you can write torque as R cross product. Cross product also you all should remember. But one thing again, R perpendicular is different. This is not simple position vector. This is perpendicular displacement. Perpendicular displacement that occurs. Perpendicular distance between axis of rotation, and the line of action. And the line of action. So one axis of rotation is there. Like here, I took this axis of rotation, the y-axis as the axis of rotation. This I have taken as the axis of rotation. And here the rotation motion is occurring. Right. So perpendicular distances, this is the axis of rotation. And this is the line of action. In this line, no force is acting. So perpendicular distance between them will be this ON, that is R perpendicular. So this is the perpendicular distance between axis of rotation and line of action of force. This is R perpendicular. Or even you can say minimum distance between axis of rotation and line of action of force. Both the things you can write. But class, this formula is more important, R cross F, because cross product you have studied in the initial classes of the lesson only. So all those who are not well with dot product or cross product, please let me know. According to that, I'll have and include it in the backup class. Right now, I have not included. I just started with calculus. Now we'll start with motion in a straight line. So if by chance you all require cross product and dot product, so when we'll do motion in a plane, we'll include vectors as well. So let me know whatever you all need, according to that I'll go. So for the backup classes also, no, those who want to have, like Aram and all, they already had their classes. Aram, Abdullah, they were from the beginning. But Tereem, Talha, Yusuf, you all were not there, Jania. So if you, whatever you want, just let me know. Even if you don't want to attend the class, you want to attend the class, you want to have some extra class for the backup accordingly, let me know. Like Tereem had told me, Tereem has initially told me how she wants to go about with the backup and the classes that are going on. So torque is equal to R cross air. Now, direction of torque is also there. Why direction of torque is there? Because torque is a vector quantity. This is a vector quantity. So it will be having its SI unit as well as it will be having its direction. Can anyone tell me what should be the SI unit of torque by looking just at this formula? Look at this formula. What should be the SI unit of torque? R position vectors SI unit multiplied by forces SI unit. What should be the ultimate SI unit of torque?
Newton
Newton,
meter.
Newton meter. Correct. Good, Aaron. It will be Newton meter. Only Newton multiplied by meter. By looking at the formula, you all can derive the unit. And this direction is actually given by right hand thumb. This is given by right hand thumb rule. See, if you place your fingers along the radius vector r, fine. If you place all your fingers along the radius vector r, like I'll show you here. If you keep all your fingers towards the radius vector r, right, and you curl your fingers towards the direction of force. So force, if you keep your palm towards the radius vector and you curl your fingers, so thumb will point outwards. This I'll show you in the next class only. I'll open my camera and I'll show you how to solve this. Right now, my camera is not working. Because of the internet issue only, it is breaking in between. So that's why I've not opened up the camera. Otherwise, in the next class, I'll tell you this better. I think that will be much better if I say it. So I think till here, note it down, because without the direction, it will become a little difficult. Note down all these basic points of torque, note it down. Those who will complete the writing part till here, you all can leave. One discussion was left, that was regarding angular momentum. That all we'll do in the next class.
Thanks a lot.